Welcome to Section 2 of the API 510 Exam Preparation Guide. Section 2, References. This is Section 2 of your API 510 Exam Preparation, References. This section identifies the codes and standards referenced throughout API 510. In the examination, questions from this section test your ability to identify the correct standard for a given activity. Focus on the association between each code and its function. They are PI 571, Damage Mechanisms Affecting Fixed Equipment. PI 571 provides description and identification of damage mechanisms. API 579-1/ASME-FFS-1, Fitness for Service. PI 579 provides assessment procedures to evaluate in-service damage. API Recommended Practice 580 Risk-Based Inspection. A PI Recommended Practice 580 provides guidelines for establishing RBI programs. API Recommended Practice 581 RBI Methodology. A PI Recommended Practice 581 provides quantitative and qualitative RBI methods. ASME Section 8 Division 1. It provides rules for construction of pressure vessels. ASME Section 8 Division 2. It provides alternative rules with higher design accuracy. SME Section 5, Non-Destructive Examination. This includes UT, RT, MT, PT methods. ASME Section 9, Welding and Brazing Qualifications. This includes qualification of welders and procedures. NBIC, National Board Inspection Code. This provides guidelines for repairs and alterations. PI 572, Inspection of Pressure Vessels. This provides inspection practices for pressure vessels. Section 3 of the API 510 Exam Preparation Guide. Section 3, Definitions. This is Section 3 of your API 510 Exam Preparation, Definitions. This section defines the key technical terms used throughout the code. In the examination, these definitions are tested through calculations, scenarios, and interpretation. Focus on formulas, pressure, temperature, and thickness relationships. Part 1, Pressure and Temperature. Maximum allowable working pressure is the maximum pressure permissible at the top of the vessel at the designated temperature. Minimum design metal temperature is the lowest temperature at which the vessel is designed to operate. Design pressure is the pressure used for design under the most severe condition. Design temperature is the temperature corresponding to the design pressure. Part 2, Thickness and Corrosion. Actual thickness is the thickness measured during the current inspection. Required thickness is the minimum thickness required for pressure and temperature. Nominal thickness is the original thickness before corrosion. Corrosion allowance is added thickness to compensate for metal loss. Corrosion rate is the loss of metal divided by the time between measurements. Part 3 Formulas. Very important. Corrosion rate is calculated as initial thickness minus actual thickness divided by time. Remaining life is calculated as actual thickness minus required thickness divided by corrosion rate. Part 4 Inspection terms. A condition monitoring location is a designated location for repeated measurements. An internal inspection is performed from inside the vessel. An on-stream inspection is performed while the vessel is in operation. An external inspection is performed from the outside. Part 5 Engineering terms. Fitness for service determines if equipment is suitable for continued operation. Risk-based inspection evaluates probability and consequence of failure. A repair restores the vessel to safe operating condition. An alteration changes pressure containing capability. A re-rating changes design pressure, temperature, or MAWP.